Welcome back. Today we're going to go over independent events. So in this one we need to review the process for multiplying fractions, and with that one, fractions, we just go ahead and multiply the numerators times numerators, denominator times denominator. And then that one will go ahead and be 3 times 1 is 3, 2 times 4 is 8, so 3/8. And then in this one as well, you can reduce before multiplying if you feel so inclined. If you don't, then you'll have to reduce after. What I mean by that is 4 can divide it by 8. So both of those can cancel. This would be a 1 and a 2. But if you don't, you would multiply and you would get 4, or 1 times 4 is 4, and then 8 times 5 is 40, and then 4 divided by 40 would reduce down to 1/10. So beforehand, if you just reduce it from the get-go, this one reduced to 1, that would reduce to 2, and then that'd be 1 times 1 is 1, 2 times 5 is 10. Same thing with this one. 1 and 3 can reduce, or sorry, not 1 and 3. 3 and 9 can reduce, and so we would have 3 and 9 that goes into it 3 times, so that would turn into a 1. This would turn into a 3. 2 times 1 is 2. 3 times 5 is 15. So then we would go ahead and get 2/15 as an answer there. All right, so independent probability. We talked about dependent versus independent, and I felt like a lot of you had a tough time grasping what that actually meant. So hopefully this lesson will help with that. But when we talk about independent probability, we're talking about something that if you have an event, it does not impact the second one. So an example that we used in there was flipping a coin and rolling a number cube. Now, if I flip heads, that's not going to change the result of the number cube. The number cube is going to roll whatever it wants to roll. So I can't, that's an independent probability. It's not dependent. It doesn't depend on the other one. But if I were to say take coins out of a bag, if I take a coin out of the bag and I leave it out of the bag, that changes the results of the second time I pick. So you have to know the difference between independent and dependent. Now, in this one, independent probability can be found really quickly by multiplying the probability. And it says here the probability of A and B. So if we look at that, we would say the probability of A times the probability of B. And that's going to look identical to this process up here. We're going to find the probability as a fraction, and then we're going to multiply those two together. Okay, so in this one, we're going to use our understanding of probability and independent events to answer the questions below. In the board game, cards are drawn. The student draws a card and replaces it, then draws a second card. Determine the probability of each event. So to earn 50 points, a student must draw a heart card and then an angel card. So what's the probability of drawing a heart-eyed card? Well, if I look at this one, it has 2 heart-eyed cards, and we have 1, 2, 3, 4, 5, 6, 7, 8 cards. So I'm going to go ahead and say that that's 2 out of 8. And then we have the angel. There's only 1 angel card, so that's 1 out of 8. And then I just multiply those across. So 2 times 1 is 2. 8 times 8 is 64. And that means that I have a 2 out of 64 chance, or a 1 out of 32 chance. And how I got this second number here is I just took both of those and divided them by 2. 2 divided by 2 is 1. 64 divided by 2 is 32. Okay, next one. To earn 20 points, a student must draw a sleeping card, then an angry card. So I go ahead and find out there are 2 sleeping cards. So I would put 2 out of 8 again. And the angry card, it looks like there's 2 angry cards. And then I would just multiply straight across. Now you could reduce from the start. You could reduce this to 1/4 and that to 1/4. That would make it a lot easier. But if you're not very good at doing reducing, then you can just multiply straight across and get 4/64, and then divide both of those by 4 to get 1/16. Okay, number 3. To earn 15 points, a student must draw an angry card or a laughing card, then an angel. Now, it's kind of key there, an angry card or a laughing card. So I would go through here. We have 2 angry cards and we have 1 laughing card. So I would then say that the angry or laughing would be 3 out of 8, and then the angel card would be 1 out of 8. We've already done that one. And then we multiply straight across. 3 times 1 is 3, 8 times 8 is 64, so I'd have 3/64. So I have a 3 out of 64 chance of getting that combination. To earn 5 points, a student must draw a sleeping card or a heart-eyed card and then an angry card. So we have sleeping or heart-eyed. So sleeping we had 2, heart-eyed we had 2, so that's going to be 4 out of 8. And then angry we've already done several times, that's 2 out of 8. I could reduce those to 1/2 and 1/4, or if I just time straight across, I can reduce after. So 4 times 2 is 8. 8 times 8 is 64. That would be 8 out of 64, which reduces down to 1/8. So I have a 1 in 8 chance of getting a sleepy-eyed or hard-eyed card, then an angry card. All right, next one. It says Kylie has a coin and a number cube. She flips the coin once and rolls the number cube once. What is the probability of that coin landing on tails, or she lands on tails, or tails up, and the cube lands on 4? So if I were to do that, we have the probability of flipping tails and the probability of getting a number 4. That would be 1 out of 2 times 1 out of 6, and we time straight across and get a 1/12 chance. So I have a 1 out of 12 chance of getting tails and 4. All right, there are 6 marbles in a bag. There are 3 green and 3 yellow. If you draw a marble and replace it and then draw another marble, what's the probability of choosing 2 yellow marbles? Well, if there's 3 yellow out of 6 total marbles, that means I have a 3 out of 6 chance and a 3 out of 6 chance. If it were me, I would reduce that to 1/2, because 3 out of 6 is 1/2. That's 1/2. It'll make it easier. But some of you might want to just time straight across. 3 times 3 is 9. 6 times 6 is 36. And then 9 divided by 36, that is the same as 1 divided by 4. So we would have a 1/4 chance of getting a yellow and then a yellow with replacement. Next question. One card from a deck of cards is selected. It is replaced and another card is chosen. What is the probability that the first card is a red and the second card is a diamond? Okay, so now if you don't know anything about playing cards, then that would be a hard question to answer. But for those that don't know anything, there's half of the cards are red in a playing deck. Half of them are black. And then of that, there are 4 suits. So that means a fourth of them are going to be diamonds. So I have half of the cards that are red, a fourth of the cards are going to be diamonds, and I multiply those probabilities together, and I would get a 1/8 chance of pulling out a red card and a diamond card for the second one. Next question. What's the probability of flipping 3 heads in a row? Well, the probability of flipping heads on a coin is 1/2. The probability of flipping heads is 1/2, and the probability of flipping heads is 1/2. So that would be 1/2 times 1/2 times 1/2, which 1 times 1 times 1, again, 1 times 1 times 1 is 1. 2 times 2 is 4, times 2 is 8. So I'd have a 1/8 chance. If you were to flip that coin, you have a 1/8 chance of getting heads 3 times in a row. Neil goes to the pet shop and selects a treat for his dog. He chooses one, returns it to the bunch, and then chooses another. What's the probability that Neil selects a bone and then a collar? Well, there are 3 bones here, and we have 1, 2, 3, 4, 5, 6 items. So he has a 3 out of 6 chance of getting the bone and a 1 out of 6 chance of getting the collar. So we would multiply 3 times 1, which would be 3, 6 times 6, which would be 36, and that can reduce. Both can divide by 3, and that would return 1/12. So he has a 1/12 chance of selecting a bone and then a collar. Next question. Dexter has 4 different coins in his pocket. He randomly selects a coin from his pocket, replaces it, and then selects another coin. What is the probability that both coins are dimes? Well, it says he has 4 different coins in his pocket. So if he has 4 different coins, that means he has a 1 in 4 chance of getting the dime. He'd have another 1 in 4 chance of getting the dime, and that we would multiply those two together. So I would go 1 times 1 is 1, 4 times 4 is 16. So he has a 1 in 16 chance of getting the dime twice. All right, next question. The letter of the alphabet, they're written on, let's see, the cards here, and then we replace it in the brown paper bag. What is the probability of drawing a vowel and replacing it and then drawing another vowel? Well, if I were to take this information, I need to know what the vowels are. And in this scenario, we're considering A, E, I, O, and U. So that means that we have 5 total vowels that we're looking at. And of the 5 total vowels, there's 26 letters in the alphabet. So I would say we're going to choose a vowel. There's 5 out of 26 chances. Then we have to choose another vowel once we replace that back in the bag. 5 out of 26 chances. And this one I can't reduce, so I'm just going to go ahead and go 5 times 5, and I'm going to get 25. And then we're going to go 26 times 26 and get 676. And then from that, I have a 25 out of 676 chance of getting a vowel and then another vowel. Next question. 2 number cubes are rolled sequentially. What is the probability that the first cube shows a 2 or a 3, and then the number cube shows an even number? Well, the probability of getting a 2 or a 3, that's 2 out of 6. I have 2 favorable outcomes out of 6 total. And then the number cube showing an even, I'd have 2, 4, 6. That's a half a chance of getting that. So I'm going to go ahead and go 2 times 1 is 2, and then 6 times 2 is 12. And then 2/12, that can reduce because both can divide by 2. So I'm going to divide both those by 2 and get 1/6. If you haven't been doing so, go ahead and pause right now and try the next one. Make sure you guys try these on your own. Don't just watch what I'm doing. Like, you should be trying each question before I attempt it if you have an idea of what to do. If you need to watch a couple, then try it, go for that. But you need to be practicing these while I'm going through it. Please take that opportunity. Next question. Mackenzie chooses one candle, returns it to the bunch, and then chooses another candle. What is the probability that Mackenzie selects a polka dot candle both times? Well, the polka dot candles here, we have how many total candles? 1, 2, 3, 4, 5 candles, and there are 2 polka dot ones. So I have a 2/5 chance times a 2/5 chance, and those 2/5 chance, I can't reduce anything, so 2 times 2 is 4, 5 times 5 is 25, so I have a 4 in 25 chance of getting a polka dot than a polka dot. All right, I hope this was helpful for you. If you have any questions, let me know, and have a great day.